Hey everyone, another video lesson for today. Today we're going to talk about empirical and molecular formulas. What are the coolest things that we can calculate? Just by given like the mass of something, you can literally find the formula. Little bit of review, chemical formula. Sometimes we don't hear this term as much of like, chemical formula is basically something like that looks like H2O. It is the element symbol. And then there's usually, if there's more than one, a little box and that has a subscript in it. Just like this, H2. We also have an oxygen in there. Just get right into it, I guess. An empirical formula is a formula that we see most often. This is when all elements in the formula have the least common multiple, or as I like to call it, the simplest ratio. Okay. On the other hand, we also have something that is what we call a molecular formula. And a molecular formula is when a chemical formula can be simplified. Okay. Sometimes the molecular formula is the empirical formula. Let's just look at some examples really quick. Let's look at something that is H2O, let's look at N2S2, and let's look at C6H12O6. Okay. We have hydrogen and oxygen in this one. We have 2 hydrogens and 1 oxygen. We cannot simplify anything less than 1. So this is an empirical formula. Here we have a nitrogen and a sulfur. We have 2 nitrogens and 2 sulfurs. We can absolutely simplify this. N2S2 is a molecular formula. You know, dinitrogens, disulfur has to have 2 nitrogens and 2 sulfurs, but the actual strand of, or the chain that kind of binds them together, it's the same thing as having 1 of each, or having 3 of each, or having 4. However, like sometimes, you know, it's either cheaper to make it this way or it's, you know, more effective in some way. So how would we write the empirical formula of this? We would write NS. And the last one has 3. We have carbon, hydrogen, and oxygen. There's 6 carbons, 12 hydrogens, 6 oxygens. We can absolutely simplify this, divide them all by 6, 1 carbon, 1 oxygen, 2 hydrogens. So glucose itself is a molecular formula. If we wanted to write the empirical formula, we could do CH2O. Okay? That's no longer glucose, but that is the empirical formula of glucose. Now, what we're going to be focused on really is finding an empirical formula. And there's really two ways that we can assess questions that ask us to find the empirical formula. The first part is if we're given mass. Okay? The first step that we do is we convert all elements to moles of that element. So we're going grams to moles, and we do this by finding the molar mass. Do that looking at the periodic table, okay? The second thing is, and this is kind of like the most fun part, is divide by the smallest number of moles. And again, once we do an example, this one will become a little bit more clear. And then we should get numbers that we can feed into our empirical formula. If we're given percent, it's almost the same thing, except the first step is we need to convert to moles. Convert to grams. Okay, and then we're gonna convert all elements to moles, grams to moles. Again, we do this by finding the molar mass, and then number 3, same thing, divide by the smallest number. And again, that should kind of feed into our empirical formula. I'm going to give you 2 examples of finding the empirical formula. One, obviously, given mass, one given percentages, and then you should be able to work on your assignment for the rest of class. Let's do a 60-gram sample of gasoline contains 38.43 grams of lead, and lead is PB. It also contains 17.83 grams of carbon. It also contains 3.74 grams of hydrogen. So we know that the formula of gasoline has lead, carbon, and hydrogen in it. Find the empirical formula. Okay. Pretty straightforward. We are given grams in our question. So this is given mass. And the first thing we need to do is we need to convert all of these to moles. So number 1, convert all elements to moles. And the way that we do that is, we've been doing it this whole time, really. We are going to take 38.43 grams of PB, 17.83 grams of carbon, and 3.74 grams of hydrogen. And we're going to do exactly what we've been doing for the last few weeks, just convert all that to moles. Now, I calculated the molar masses already. Well, I didn't really calculate it, but I looked them up. If we go to the periodic table, we're going to see that the molar mass of lead is 207.2. The reason I put it on the bottom is because I want to cancel it. We know that 1 mole of carbon is 12.01 grams of carbon. You can look that up on the periodic table. And again, the reason that the moles are on the top is because we want to cancel grams of carbon. And then, of course, hydrogen is 1.008 grams of carbon, grams of hydrogen. And then that equals 1 mole of hydrogen. And again, grams cancel, we want to go into moles, so moles always has to be on the top. Well, moles has to be on the top in this case. If we do this math correctly, we should get 0.185 moles of Pb, 1.48 moles of carbon, and 3.70 moles of hydrogen. Okay. Our second step is to divide by the smallest number of moles. Okay? So we have 0.185 moles of Pb, 1.48 moles of carbon, and 3.70 moles of hydrogen. We are looking for the empirical formula, which is the simplest formula. We want there to be a 1 in there, because if there isn't a 1, we can still probably divide at some point. So we look at these three numbers, and we find whichever one's the smallest. This one is the smallest number. We're going to divide each of those by 0.185. And the reason that we do this is because we know this answer is going to give us 1 Pb. If we do it for carbon, that's really close to 8, like super close. And this is really close to 20. Now we can set up our formula, PbCH, and all we have to do is put those values in their appropriate boxes. And the empirical formula for gasoline is PbC8H20. Cool? Let's do another example, but in this time, let's give percent instead of grams, because it's one extra step. A compound is found to contain 63.52 iron and 36.48, sulfur. What is the empirical formula? Okay. What's nice about these two numbers, you kind of see this immediately, is that 63 plus 0.52 plus 36.48 equals 100%. And it really should equal 100% because we're looking at 100% of the substance. So our first step is to convert to grams. And this is so simple. I'm going to give you the long-winded answer. But all we really have to do is, instead of saying 63.52%, we're just going to say 63.52 grams, 36.48 grams. If the values add up to 100%, you can assume you have 100 grams, which makes it a lot easier. And again, I told you I was going to give you the long-winded answer. If this is circle, if we fill the circle, we'll have 100% of the circle. Okay? 63% is about a little more than half. So this is going to be iron. And this is going to be sulfur. Now, if I told you that this equals 100 grams, then we know we have exactly 63.52 and 36.48. But instead, we have grams of each of these. Okay? It's just an easy way. It's just kind of quick math. So when we convert to grams, in this case, we have 63.52 grams of iron, and we have 36.48 grams of sulfur. Now we're going to convert to moles, and we know how to do this. It is exactly what we did in the other problem. We're just going to convert these two values to moles. 1 mole of Fe is 55.933 grams of Fe. And then 1 mole of sulfur is 32.066 grams of sulfur. And again, my values might look a little bit different than yours. I don't know if we're using the same periodic table. I also have both of these memorized this gives us 1.135 moles of Fe. This gives us around 1.37 moles of sulfur. Again, it should be obvious what the empirical formula is, but our last step is we're going to divide by the smallest amount, or the smaller amount. We have 1.135 moles of Fe, 1.137 moles of S, 1.135, 1.135. This is so close. Literally, this is 1. This is so close to 1. So our empirical formula is FeS. Both of them are 1. Very last thing. When dividing by the smallest amount, you may get a decimal. So let's say like X is 3, Y is 1.5, and Z is 8. Technically, your empirical formula should look like this. X 3, Y 1.5, Z 8. This is the simplest ratio. However, we know that we can't have 0.5 of an atom. So what we're going to do here is we're going to multiply all of these by 2. So our new empirical formula is X6, Y3, Z16. This is still the simplest. You cannot divide 16 by 3. So it's still the simplest formula. It's still an empirical formula. Okay, you might see this on your homework, so be careful. Do not just round this up to 2. This is a big don't. You have to multiply everything. This is the ratio, 3, 1.58. 6, 3, 16. All we want is whole numbers. Whole numbers are good. Decimals are bad. Cool. Hopefully this makes a little bit of sense to you. Usually it's people's it's usually people's favorite lesson in the